Hi, this of course is Roger, and I've been asked by the people in the shop to talk a little bit about tanks and tank safety. So I guess it's time for that dreaded safety lecture. Here in the shop, we have several highly explosive tanks. Uh, this one has acetylene. This one is propane, and this is oxygen. Now, any one of these containers has got plenty of power to hurt a person if you don't know how to handle them safely. The first thing that we're going to talk about will be the difference between these two tanks and this tank, because they do two different things. These tanks both contain flammable gas that will burn in the presence of oxygen. This green tank is oxygen. And notice the lines coming off of it are green. Notice this is a very old line, but it used to be green. So if you ever want to know the difference when you see lines, the spaghetti here in the shop, you can tell at a glance by looking for the color red or the color green. Red always means gas or flammable gas. Green always means gas, but oxygen gas, which is necessary for combustion. So when you have a oxyacetylene handpiece like this, you've got the two gases feeding into the same handpiece or machine. This one here goes to the acetylene tank, and it just burns acetylene, and these little holes here are where it gets its oxygen from the air. This is a very easy torch to learn on. This is the torch I learned on. This handpiece is at least 50 years old. This one is oxypropane, and this is propane in this tank, just the same as you would put in your barbecue or something that you would cook with. But again, it's a very hot torch, and that's because you can add oxygen to the flammable gas. So just kind of review for a second.
Oops. Cut.
Cut. That's a species spicy meatball. Take 40. So the first thing I'm going to do is I'm going to describe the tanks and the parts of the tank. Here you have your oxygen tank. This is your acetylene tank, and they both have a stem. Even the propane tank has a stem, and that stem leads to a main control valve. You see the main control valve here, the main control valve here, and down here you have another small main control valve. The main control valve is where you turn the tank on and off. If you don't want gas coming out of this tank, turn the main control valve. And on the very top, when you look down at the top, all main control valves have a pair of arrows. One points this way to the right, and the other one points to the left. Always remember, righty-tighty, lefty-loosey. So when you're turning a tank off, you turn it to the right. That makes the tank tight. Same way here, same way down there. If you want to turn the tank on, lefty-loosey, lefty-loosey, lefty-loosey. Now we have all three tanks are on. Now, at the beginning of the morning, quite frequently you'll turn the tanks on lefty-loosey. At the end of the day, you always check every tank in the shop and make sure that righty is tighty. Now, these valves were designed to open and close. You don't need a hammer, you don't need a wrench, you don't need to do anything pushing hard. They open just hand tight. The same kind of pressure you would do in a handshake. That's how tight you have to turn them. Now, so you have your tanks. So what are these things? Well, I'll tell you what these things are. These are called regulators. And what they do is they regulate the pressure of the gas in your lines. If you want more gas, you turn the regulator to the right, and you can see this little it has a name, a dial. It's got a dial with a pointer. You would turn this on and turn this to the right, and the pointer goes up. Right now it's reading at 200 pounds of pressure, which is way too much. So I'm going to turn it back down again. And when you're adjusting the pressure, you do it with the valve open, and that will give you a more accurate reading. Right now it's dropping from 200 down to 100 pounds. It's continuing to drop, and here we're down to, and what you generally want for oxyacetylene, and I've got this open, and I'm slowly, helps the tanks on. Let's do this over again. Cut! That was some species spicy, a meatball. I'm gonna turn this bad boy down, and okay, it's 200. It's dropping, dropping, and the smell of oxygen. Oxygen can't hurt you. It's in the air all around us. Okay, now we're dropping slowly. Okay, now I'm down to 0, and I'm slowly bringing this up and to about 10 pounds. Your acetylene, same deal. Right now the acetylene is set on 10 pounds. There's another dial right here. This dial tells you how full your tank is based on how much pressure it has inside of it. When this reads 0, if you suddenly run out of oxygen or you suddenly run out of acetylene, and you notice that this dial is on 0, that would mean the tank is empty. Fools me all the time, you know, who knows when your tank is empty. They last so long. So now, you have the third regulator over here, and you'll notice this is a single stage regulator. This is a dual stage regulator. It has 2 dials on it. This one here is a single stage, and if you want to increase the pressure, you turn the knob on the regulator to the right, same as all the other regulators. If you want to turn it down, turn it to the left. But for the most part, we don't change the regulator much. The one thing you would do in an absolute safe situation is at the end of the night, you turn your tanks off and you turn your regulator all to where it opens freely to the left. That means even if this tank was on, you would have 0 pressure here or no gas coming out of the lines. So that's the absolute safest way to do it. In the morning, when you start up, you turn your tank on and you turn this to the right until you, and don't forget to open your valve. you turn this to the right and open the valve until you get your 10 pounds pressure. It's pretty easy. The same deal would apply to these guys here. Quite frequently here in my shop, I'm totally pleased as punch if you just turn off the main valve. And again, repeat after me. Righty is tighty, lefty is loosey, so you turn it to the right when you want it to be off. It's a little bit confusing with your regulator here because you're turning it to the right to get more pressure. Just how it is, doesn't have to make sense.